Today, our young scientists and young popularizers of physics will show you a few experiments on physics, and one of the experiments I'd like to show you right now. Let's look to this U-shaped vessel. There is just water inside it, and there is special electrodes. Let's supply DC current into this vessel. We can see bubbles inside it, and these bubbles goes to the up part of this vessel. And we can take these new volumes of some gases and mix it into this tube. Let me show you. And now I'm taking my lighter, and let's see what will be happen.
Today I want to tell you a short story about science, modern science, and a little bit about our laboratory. And science is a type of human activities which collect and organize our knowledge about the universe. And of course, such type of activity looks very exciting for people and has a great influence on individuals and entire societies both. And about some particular things which science can give us. For example, works of such great scientists like Maxwell and Hertz in the field of electromagnetic radiation gave us such new technologies as radio, Wi-Fi, near-field communication, and mobile network. And all these technologies significantly increased our communication. Of course, individuals also very curious to some things about our world, and I feel very inspired when I can find something new and something interesting. And about me, I'm mostly interested in modern optics and more specifically in integrated photonics. This field of science studies some small devices with elements which has dimensions comparable to the wavelengths of radiation. And of course, production of such device requires complicated and rare equipment, and sometimes it's very hard to find a place where you can do such work. And I'm a lucky one because our laboratory provided me with such equipment, and now I can successfully carry out my scientific activity. And about laboratory is not only about equipment. The main part in laboratory is the people, and especially the head of laboratory, because the head of laboratory carries responsibility for future achievements and possibilities to work for all these people. And the head of our laboratory is a famous scientist, Grigory Goldsman. And Grigory Goldsman had an annual I3 award from Institute of Electrical Electronic Engineers for his continuous contributing to study and development of applied superconductivity. And also under his supervision, many worthy doctors and postdocs in physics have graduated and became able to study our world. And I think it would be great if everyone had a chance to do what one wants and achieve some inspiring results in this field.
And today I want to tell you not only about the experimental scientists, but also about those who popularize the science.
Hello, my name is Sergey.
And I am Alexandra.
And let's start our conversation with a short question. How does natural science knowledge affect our life?
In our life, we have motion of different bodies. So, for example, we have the trees, which are the leaves which are falling from the trees, or the trains which go in the subway. The study of this motion is called mechanics. So, we will show you two basic experiments. First experiment consists of the cylinder and inclining plane.
And everybody knows, even each child can answer you that every object in our planet should go down the mountain like a skier slides down easily the mountain from the top.
Okay, let's start from the experiment. We have a cylinder, which is a basic cylinder. We will place it on the plane and see what happens. So we place it and see that the cylinder goes upstairs. So we need to know why it goes. It's here. So Sasha.
It's very interesting, and I have no idea why this is happening. Maybe it's just a magic.
Well, magic is a simple answer, but no.
Okay, now we need to check how the slide works. For this reason, we turn it around.
So let's see. We place it. We can see that it goes downstairs or upstairs. So
Okay, in such case, it means that it does not, our experiment does not depend on the slide position, but I see that the cylinder can move as upstairs, it can move downstairs and stand at the point. It means that there is something with our cylinder. And now I feel that one side of the cylinder is much heavier than another. It means that we deal with dislocated center of mass. Okay, let's check.
indeed, we can check this. We can open this cylinder. And we can clearly see that there are some massive objects. So if we will place it on the inclining plane, like this, and release it, we can see that this massive object always goes downstairs, so like this, or like this.
Okay, now we can see that the center of mass of the body always want to be in the lowest position. And in both cases, when the body goes up and goes down, the center of mass is in the lowest possible position.
So let's switch to the second experiment. It consists of the inclining plane, a cylinder, and the beacon. So let's start with the cylinder and place it on this inclining plane.
It goes down.
Now let's place a beacon.
And beacon goes up.
Do you know why?
No, but we want to try to solve this riddle. So, in the previous experiment, we understand that they deal with the center of mass. Center of mass always want to be in the lowest position. So here I feel that the cylinder is uniform. Each part of the cone have the same weight, so it means that the center of mass coincides with the geometrical center, and it's placed on the axis which connects these two spheres. So let's take a look again, and we can notice that actually the center of mass of this beacon goes down, and we can check it in this way. So we need a ruler and measure the distance. It's about 15.5 centimeters height. And at final position, the height is smaller. It's about 14.5. So it means that center of mass takes the lowest position at the final point.
Hello,
My name is Alexey, and I love listening to music. And I start playing the guitar. And of course, I love physics. And like any beginning musician, I have a dream to create my own band with original sound. But for this, we can understand what is the sound. To understand this, let's look at my guitar. I can extract different sounds just playing the strings. Let's look at only one string and think about how sound is produced. It's a very interesting question because sound is a vibration, and to create it, I just hit the string, and I wonder what the regularity is in arrangement of the strings, and can different geometrical objects make musical sounds. And Nastya playing the xylophone will help us deal with it.
Hello, it is simple. Our xylophone consists of wooden bars of different lengths. Let us compare how do different bars sound. Which sounds lower, which sounds higher. So, which one sounds higher?
Yeah, I think shortest.
Yes, that's right. And this is because each bar vibrates with its own frequency. And the same thing happens with the guitar string.
Oh, I wonder, will sound change if we take only wooden bars of different lengths and throw them? It's amazing. We have the sound like as Nastya's xylophone. It's turned out that the geometric objects of different shapes and of different materials can emit different sounds of different tones. But the musical sound is obtained for object with a very simple form. For example, wooden bar or a string.
I also play flute, but I wonder, what is vibrating in this case? To answer this question, let us consider the following experiment. We have organ pipes of different lengths, and we will blow air through them, causing the vibrations of the air column in the pipes. Yes, and let's... Depending on the size of the pipe, the sound will have different pitch. And the air column in the pipe plays the same role as a guitar string or a wooden bar of xylophone. The longer pipe produced the lower sound, and the smaller pipe produced a higher sound. We can see that depending on the length of the pipe or the air column in the pipe, the sound will have different pitch. Now we can easily understand how my flute works. The air column in the flute changes depending on the position of my fingers. So, and the three main points are vibrating body is the source of sound, the elastic media is a transmitter, and our eardrum is the receiver. And now try to answer the question yourself. Will you hear an explosion in space?
And now, having figured out how sound arises, we want to demonstrate you the performance of our musical group.
Hello everybody.
Hello.
We already talked about science, and let's talk about scientific equipment and the science which describes this equipment.
Okay, Ilya, but I thought that we will talk about optical fiber, but it does not look like optical fiber.
Yes, we will talk about waveguides, but actually it's the same. It just consists of the array of the optical fibers, and let me explain you how it works.
Okay.
Let's see, we have a laser source, and let's shine a light through this core, and we can see the light on the other side, I hope. And I demonstrate it to you. Can you
Yes,
see
I
something?
see it. Yes.
That's good. Then let me explain you the physics of this event. We have these thin fibers, and we have outer core. Also we have inner core, and light propagates only inside the inner core. It's always reflected back inside the inner core and never goes to the outer core. And therefore we have the event of total internal reflection. And we have no absorption at all, and that's all, I think. That's the idea of this
Ilya, it was really very interesting, but what about, let's consider, for example, several natural phenomena from the scientific point of view. What do you think about it?
Yes, it's a good idea. Let's talk about why we can actually see everything, why we, for example, can see the moon in the sky.
Yes, I'm also interested in it. And for example, why does it shine, but we can't see the light which goes to the moon surface, for example. But I can show you a very simple experiment. We have a laser and I can turn it on, but you can see the light here. Do
Yes,
you agree with me? Yes. But now I can use my hand like an obstacle for it, and now you see that we have some spot of light here.
Yes, but we can see only the end of the beam, but we cannot, maybe turn it again, but we cannot see it, the whole beam. It's not interesting. Maybe we can do something.
Let's try to think about it together. We have some kind of special device. It is a humidifier, and for example, I can use it, and now we see the beam of light. It's beautiful, I think. And why do we see actually, and how can we see it? Now the light reflects from the droplets of water, and you can see the beam of light immediately. And the moon in the night sky can't shine itself. And now we analyzed our experiment, and we have already understood that the rays reflects, and we can see the moon on the night sky.
Okay, that's fine, but we'll only talk about the straight lines propagation of the light, but we know that light can propagate by the curves.
Yes, yes, I agree with you. It is an interesting question, but maybe we want to show the next experiment.
Okay, let's make our experiment, and we have just a vessel with water, and let's shine a laser through it. And you can see that it's not simple water, because light is a little bit curved, as you can see here. And let me explain you why it happens. Actually, here we have a solution of the sugar and water, and here we have just water. And therefore, we have different refractive indexes here and here. And we have a reflection of the light during the propagation of this light.
Now I understand it, but what about mirage, Ilya? How does it work?
I think it's a good question, because it works almost the same, but now we need to consider that it's not a water, but it's an air, because we see mirages through the air. And let's assume that this part is hot air, upper part, and the lower part is cold air. It may be opposite, but it doesn't matter anyway. And let's see what will happen. But now let's assume that our laser is now our object, and we are located somewhere here. We are kind of observer, and we see this laser. And interesting situation, because our brain doesn't know that light goes by the curve. It thinks that the light always propagates by the straight lines. And therefore, it will think that object located somewhere here, a little bit upper, to the tangent line of this point, of this trajectory. And we think that the laser located somewhere here. And therefore, we are able to see the mirages. And in reality, for example, let's do it again. Here will be the sky, for example. It will be ground. Kind of we put everything upside down, and then we will think that our sky is become a little bit lower, and therefore we see the sky on the ground. It is strange. You see something blue, the sky on the ground, and you may assume that, wow, maybe it's water, something blue on the ground. But no, it's just a mirage. It's just a part of the sky which is reflected.
Ilya, thank you very much. The world around us is really amazing.
Мы убедили вас, что наука вдохновляет и зажигает. Чем занимаются ученые? Ученые занимаются исследованиями, ученые проводят просветительскую работу, популяризируют науку. Зачем нужно заниматься просветительской работой? Затем, чтобы рождались новые ученые, затем, чтобы большему количеству людей на планете становилось интересно устройство мира, было доступнее образование. Меня зовут Ксения Теплякова, я являюсь директором Центра социальных инициатив МПГУ и руководителем проекта «Физическая гостиная». Мы уже много лет занимаемся просветительской деятельностью, наши проекты получили одобрение Министерства науки и образования Российской Федерации, Департамента образования и науки, Российской академии наук, благотворительных фондов. Мы проводим как масштабнейшие фестивали науки на 1000 человек в ВУЗе, в парках, выездные какие-то мероприятия, так и занимаемся волонтерством просвещения. Что такое волонтерство просвещения? Это когда люди работают с теми, например, детками или взрослыми людьми, подростками, у которых нет возможности сейчас посещать дополнительное образование, получать обычное образование. Это дети могут проходить длительное лечение в больницах, находиться в детском хосписе. Им всем интересно, как устроен этот мир, им всем хочется разобраться в каких-то сложных вопросах. Часто нашей задачей является подружить школьников со школьной программой, показать, что формулы и законы, они вообще доступны каждому, и что все, что окружает нас, можно объяснить с помощью науки. Ученые-исследователи, ученые-популяризаторы науки и, конечно же, ученые-романтики. Ведь, глядя на такую красивую розу, мы ей не только восхищаемся, мы не только ей любуемся и дарим друг другу, но мы и хотим изучить ее свойства тел при низких температурах. С годом науки вас! И всем желаем новых открытий и интересных событий в жизни.